Hello and good afternoon, and welcome to this video tutorial, which is going to be on the CCNP version 7 route course, and this is lab 2-2 EIGRP stub routing configuration. And I've actually had already posted a 90-minute tutorial on this. However, there was something wrong with the audio, and I'm not sure what went wrong, but it was extremely garbled, and when it got posted, it got even worse. So I'd like to definitely give a special thank you to DUANE down in Fort Gordon, Georgia, who was kind enough to send me an email indicating that there were some issues with the audio, and then I went back, pulled it up on YouTube, and it was definitely in some bad shape. So hopefully the audio on this video is going to be super clear, and we've got a lot to discuss here. So the scenario that we're dealing with is we want to try to improve our network stability and reduce resource utilization on the headquarters network that we've decided to configure. And what we've done is we've decided to configure router 2 to be a stub router, right? So router 2 is going to be our stub router. And I have already done all of the sort of the base config work via a TCL script. So we've got all of our IP addresses are set up. So let's go ahead and hop on to router 1 here. We'll go from user exec to privilege exec. I'm going to do a show IP interface brief. And if you're following along, I'm on step 1B, or 1C actually. And so you can see we have our interfaces are up there. The loopback interface is up. The serial 000 interface is up. Let's get on to router 2. And we're actually going to talk about quite a few things. And we're going to find out why EIGRP, which was Cisco proprietary for a very long time, an internet draft was submitted to the IETF by Donnie Savage. And we're going to take a look at the draft, and we're actually going to see a lot of people say that the stub feature, and this is actually true, that the EIGRP stub feature that we're looking at right now was not included in the IETF draft. And I actually was very fortunate this past week at Cisco Live 2015 in San Diego. I got to speak with Donnie Savage for about 15 minutes and asked Donnie about why the stub feature wasn't included. We talked about some of the debug information, and then we also talked about what I referenced in my other video on the EIGRP stub routing configuration, which is why in this lab, and we'll see this, it comes up right away in step 2, why we sometimes will end up with a static route that shows up as a directly connected EIGRP route. And so I'll configure our router here to do the same thing real quick and then flip it back just so that we can take a look at it. If you want more information, definitely check out my other video on lab 2-2 that is basically called lab 2-2B, I believe it is, bonus. And it goes over that unexpected behavior, or so, I guess the unexpected results of that behavior, but the behavior is 100% what EIGRP is supposed to do. All right, so we're going to jump in right now, and let's go ahead and get EIGRP configured up here. So on router 1, we're going to go from privilege exec to global config, and I'm just going to simply say router EIGRP 100. And now we're going to use this network statement, and we're just going to throw it on there. I'm going to put the no auto summary keyword on too. And so you'll notice I'm not trying to specifically define the interfaces that EIGRP is running on. I'm leaving it kind of wide open to that whole 10.000/8. If I were to say do show IP protocols, you can see that it shows that EIGRP is running, and we've got auto summarization is disabled. Now this is important because when I say do show run section EIGRP, do we have any code here or configuration information that says no auto summary? Now remember I entered it in up here. I typed in no auto summary, however it doesn't say anything here. And that's typically, you'll see that 99% of the time with Cisco, where the default configuration or the default config is not going to be shown. And this is another case where this is on automatic summarization is disabled by default. So when I type no auto summary, it doesn't show it here for the simple fact that it's already on. And we'll see that when we transition over to router 7 as well. All right, so that's it for, or I'm sorry, router 2, I should say. So here's router 2. It's actually my router 7, but I rename it to router 2. All right, so let's go ahead and go into global config, and I'm going to say router EIGRP 100. We're going to go ahead and throw that wide cast net there for the 10.0.0.0/8, and there you go. Our adjacency just popped up, and I'm also going to say network 192.168.0.0, and we're going to say 0.0.255.255 for a /16 on our network statement there. Now, again, if I say do show IP protocols, you can clearly see I didn't type no auto summary, and you can see here that in fact it is disabled. So if I were to go ahead and say no auto summary, it's not going to change anything, and it's still going to say it's disabled. And if I say do show run section EIGRP, you can see that it doesn't show up in our config. And again, that's because it's on by default. All right, so now we're going to summarize router 2's loopback interfaces. As you can see here, we have a series of loopback interfaces that we're going to use to our advantage here and for demonstration purposes on how to do the summarization. And when we turn router 2 into a stub, we're going to find out how we can even do a leak map up. And so I'm going to do a leak map as well. We're going to take a look at quite a few things in this video. So let's go ahead and jump into interface serial 000. And I'm going to say IP summary address EIGRP 100. And for those 4/30s, we're looking at 192.168.0.0, and it's going to be 248.0. And if you're wondering how we arrived at that, just a sort of a quick refresher here on summaries, how to configure summaries. So we've got our interesting octet is clearly that third octet right there. So 1 has a value of 00 in decimal, or I'm sorry, in binary. 1 has a value of 0000001, and I'm going to leave these 4 bits off here so we don't end up drawing a whole bunch of zeros. That's the value for 2, the value for 3, and then the value for 4. So when we take a look at this, where does the bit boundary stop when they no longer match? And it's right here. So if I had the 8 bits from 192 that match, I've got the 8 bits from 168 that match, and then how many additional bits do we have? 1, 2, 3, 4, 5 plus 5. So what do we have? 8 plus 8 is 16, and 5 is equal to a /21. Well, a /21, what's the subnet mask for that? Well, it would be 255.255, and then the 8 bits are going to be, I'm sorry, the 5 bits will be borrowed, so we would have, excuse me, 128 plus 64 plus 32 plus 16 plus 8, and so what does that equal? So we've got 192, 224, 240, 248. And so that is how we arrive at our subnet mask, aka our CIDR notation, right, for our summary. And then again, the values here, none of these values matched with a 1, with the bit in the on position, so we end up with 192.168.0.0/21, which is 248 in that third octet. So that's how we arrived at that summary there. Okay, excuse me. All right, so before we do this, let me step over here to router 1, and let's go ahead and say do show IP route. Let's see what routes we currently see over here. And as you can see, what do we have here? We've got, whoops. In fact, let me pull this away a little bit here. So what do we have here? We've got the directly connected networks, the 10.3.3, the 10.4.4. Now we have the loopback interfaces. And you'll notice, since we're not summarizing, it's adding a whole lot of interfaces here into our address range. So let's go ahead and hit enter. And what's going to happen? We should get a soft, graceful reset. And if you come over here, you can see peer graceful restart. And everything is good. And so now let's go ahead and say do show IP route now, and what do we see? What we expected to see, which is simply our summary route. And so this route actually includes all 4 of these loopback addresses. So do I still have connectivity? So let's see, do ping 192.168.1.1. How about .2.1, .3.1, or .4.1? All right, and so you can clearly see there we've got connectivity, we've got our summary working, and again, the summary address is to kind of hide what's going on behind router 2, and it's to limit the number of entries that we have in the routing table. So now we're going to go ahead and deal with our static and our default routes. And so here's where we're real quickly, again, let's remember what did the routing table look like over here on router 1. So we only have these 3 EIGRP routes here. You'll notice there is no route for this LAN segment here on router 3. Router 3 is not participating in EIGRP, and that's why this is clearly defined here with the green triangle. So this is EIGRP AS100 over here, router 1 and router 2. However, router 3 is not running EIGRP. So let's follow the instructions here. They're asking us to configure a static route on R2 to the R3 LAN. So we're going to go to global config. I'm going to say IP route 10.1.5.0. It's a /24. Now, sorry about that. What is my next hop going to be? Right? Is my next hop going to be the outgoing interface? Is it going to be the next hop IP address? Or am I going to fully qualify it by using both the interface and the next hop IP in that order? Now, it's interesting that they're asking you to use the next hop IP. So I would say 10.4.4.2. However, what have we always been taught since CCNA when we have serial interfaces in a point-to-point configuration like we have here? We've kind of always been shown and told, we'll just simply throw the interface on there. So if I were to say serial 000. Now, let's come back over here to router 1 real quick, and let's see if the EIGRP table has changed at all. And you're probably wondering, well, why am I curious about the EIGRP table? Because router 3 is not running EIGRP. Whoops. Bring this up a little bit. And it's not. However, where did that come from? And so this is, again, expected behavior, but something to definitely be aware of, because there's a scenario which we've just encountered, right? And there's 2 conditions which need to be met here. The first condition is that we need to have a static route on the router, and that static route has to refer to the outgoing interface as its next hop. And so we've got that. So the 2 checkboxes that we need, the first checkbox is done. The second checkbox says, if I have a network statement in my EIGRP router config, that it would include the destination network of that same static route that has the outgoing interface as its next hop. What happens here is that EIGRP, and there's a couple things. iOS first. iOS checks a connected bit. It sets a connected bit on this static route, right? And once the connected bit gets set on this static route, what happens is EIGRP does what it normally does. If you have a network statement and what EIGRP is being told by iOS is a directly connected network, therefore EIGRP will originate a route to that network. And so that's the behavior that we're seeing here, and that's where we end up with this 10.1.5.0. Now it's interesting, the lab doesn't explain any of this behavior. They just simply tell you, hey, we want you to use the IP address. They're looking for you to use the next hop IP. So let's put that route back in here, .1.5.0. And they want us to use the 10.4.4.2. So let's come back over here to router 1 and let's see, do show IP route. Does it look any different right now? And it does. As you can see, that route has been withdrawn. because it's no longer having the bit set by iOS indicating that it is directly connected. And in fact, if I were to say do show IP EIGRP topology 10.1.5.0/24, you can see the topology, it's not in our EIGRP topology table at this point. Prior to this, when I referenced and I'll really quickly set it up here, I don't want to spend too much time on this because again I do have another video that goes into this in great detail. So when the interface, the outgoing interface is being used and there's a network statement that would include that outgoing interface, and where's that topology command? It now is in the topology table. You can see it sees it as a redistributed static, right? And the route is internal. Okay, so it shows it as an internal route, and that is why it gets picked up. In fact, if I say do show IP ceph 10.1.5.0/24, and that is the difference. It sees it as directly attached, directly connected, right, to serial 000, and therefore, since we have a static route that references an outgoing interface as opposed to a next hop IP or being fully qualified, it references an outgoing interface, and there's an EIGRP network statement in our config that would include the destination network. EIGRP is going to originate that route and then advertise that same route to his neighbors. And that's exactly what's happening there. So definitely be aware of this behavior. It was interesting when I spoke with Donnie Savage about this. There are a number of customers that he works with who actually use this intentionally as a feature, which was interesting. I remember when I first saw this behavior, I kind of scratched my head and I really didn't understand what was going on and how it was that that route was showing up. So definitely good to know. All right, so let's drive on. Let's go ahead and get our IP route statement in here as the lab wants us to, 10.1.5.0. And this is the reason that they're putting the next hop IP in there, right? Because if EIGRP generates that route, it kind of breaks what we're trying to do here with the static and the default route. And then on router 3, and router 3 does not see a whole lot of action in this lab, we're going to go ahead and go to global config, and we're going to set the default route right back to the next hop IP, 10.4.4.1. And so now what it wants us to do is verify connectivity between R2 and R3. So I'll say do ping 10.1.5.1, and you can see now we have connectivity. And then from R3 the same. Let's try to hit that simulated LAN network that sits behind router 2. Do ping 10.3.3.1. And so there we go. We've got connectivity between router 2's LAN segment and router 3's LAN segment. Let's do let me swing back over here to router 2, and let's do do show IP EIGRP neighbors. So there you go. You can see I only have a single EIGRP neighbor, right? So let me scroll down a little bit here, give us a little more space. All right, so I still only have that single neighbor, and we're able to see the summary. And so the question that we're posed is, does R1 have a route to R3's LAN? So if we go back over here to R1 and say do show IP route, we're going to see the same routing table. Do I have a route in here to the 10.1.5.1? And this is what, remember, when we use the outgoing interface as the next hop in that static route, that would have broken what they're asking us here, because we did have a route, right? However, when we use the next hop IP, you'll notice that we don't. And so the answer is no. Remember, R3 is not running EIGRP, and R1 has no route to get to the 10.1.5.0 network. All right, so let's go ahead and transition now over to step 3, which is going to be to configure and verify stub routing. And so remember, when we activate stub routing, right, out of the gate, what are the default network types that EIGRP will advertise when it gets set up as a stub router? And so if you were thinking connected and summary, you would be correct, right? So the connected and summary routes will get advertised by default as soon as I turn a router into an EIGRP stub. And we're going to take a look at every option that you can set and see what that does to our routing table. So as we go down to step 3 here, the first thing it asks us to do, it says configure router 2 as a stub router simply using the default EIGRP stub command. So let's go ahead and go into router EIGRP 100, and we're going to say, we're going to say EIGRP stub. Now when I do this, we're going to see some messages here. You can see it says peer is down, peer is up. So whereas before, when I was doing the summary configuration, right, that was a graceful restart, this could be a resume generating restart for you. So make sure that if you do this, that you can see here, it's going to tear the adjacency down and then bring the adjacency back up, right? And so this is definitely a destructive thing to do during the middle of the day, depending on how many neighbors you have. So now that I've changed it to a stub, let's go ahead and say do show IP route. Has anything changed? Right? Now my routes, these are the same 3 routes that I previously had right up here. Because what type of routes are these? We've got a directly connected LAN segment that's being emulated. We have a directly connected transit network here, and we have our summary. So 2 connected networks and a summary. So if I were to say, and how can I verify that? So if I say do show IPsef and I say 3.3.0 slash, is that 24? It is, dash 24, it shows the next hop is out serial 000, right? But again, it's being originated because on router 2, what kind of a route is that? Do show IPsef 10.3.3.0 slash 24. It is attached, so it's directly connected. And what if I say do show IPsef 10.4.4.0, is that right? Yep, slash 30. Again, directly connected. So that's why these routes are being originated. We turned it into a stub. So when router 2 becomes a stub, right? And let me go ahead and annotate that here. So router 2 is considered our stub router, right? Now, this would be considered the hub, and it can also be considered the distribution. And the hub distribution router is typically in a setup with EIGRP. That's the router that has connectivity out to not just the headquarters network, but probably out to where? The internet, right? And so router 2 only has a single path out of the network to get to the headquarters network and to get to the internet. And so that's why it's okay that we turn him into a stub, because he's only got one way out anyway. And so when we flip router 2 to become a stub, what that means is that on router 1, he's going to see that there's a change. And we're going to look at the type length values, the TLV values in the hello packets, because that's really what's happening here. When we typed in EIGRP stub, a hello packet shot across the link over to router 1, and inside that TLV packet, the type length value, or vector, you'll see it in the output of the debug, it's going to be called vector. Vector 6, or value 6, says, hey, I'm a stub. And when router 1 sees that, he then says, oh, okay, well then I won't query you. There will be no queries. I'm not going to query you if for whatever reason I lose a route to a network. Because remember, EIGRP, when a route gets lost, what do the routers do? Well, the router that loses the route is going to send a query message out to his neighbor saying, hey, do you know how to get to this network which I had as an EIGRP route, but that I no longer have? That will no longer happen when we make router 2 a stub. And so that's something that's very key to remember is that when you make a router a stub, you're telling your neighbors that you're no longer interested in receiving those query messages that may or may not help them find their way to a network that they've lost. And so again, so step one is the hub router stops sending queries to the stub. The second step is that the stub router will no longer propagate dynamically learned EIGRP prefixes to the hub, right? So it's sort of a two-way thing that takes place here. So no dynamically learned prefixes are going to be sent to the hub from the stub, and no queries will be sent from the hub distribution router to the stub router, right? Or sometimes you'll see this referred to as the branch. And typically it's a hub and spoke scenario where we end up with the stub router here. All right, so we can see that it's directly attached. Okay, what are we asked to do next? So on router 2, it wants us to do a do show run section EIGRP. And remember, when I said EIGRP stub, did I type options in? I didn't. However, what are our defaults, right? And this is one of those cases where the defaults are shown, and they are connected and summary. And so the question is, what EIGRP stub options are implemented by default? It's connected and summary, and they show up for you right there. All right, so we looked at router 1's routing table. We've noticed that the output is the same because, again, those are directly connected networks and the summary route. Now, also over on router 1, if I were to say do show IP EIGRP, then we're going to go EIGRP, we'll do neighbors detail, right? So this is another way to tell, based off of the neighbor, right? Router 1 says, oh, this neighbor is a stub peer, and he's advertising connected and summary routes. And so that's a way to tell on the remote router, what am I seeing? What does that remote router see me as if I'm router 2? And here you can clearly see it's a stub peer advertising connected and summary routes. All right, so on to step 4. We're going to configure and verify EIGRP stub routing options. We're going to take a look at static, connected, and summary. So let's jump back in here on router 2, and let's say redistribute static. So we're going to redistribute the static, and I'm going to say EIGRP stub, and here's some of the options, right? So we've seen connected, that was one of the defaults. We've seen summary, that was one of the defaults. Now we're redistributing, and we're going to do static, right? So EIGRP stub static, again, this is going to tear the peering down, as you saw right there. And you can see over here it was not a graceful restart at all. So we're redistributing static. Well, what was my static route? Well, the static route was at 10.150 advertisement over to the LAN segment behind router 3. So when I say do show IP route, what do we see now? Again, remember, I said EIGRP stub static, so therefore the only thing I'm going to see is this single static route, right? Because this was the only static route that we had, and I didn't say summary or connected, therefore we're only going to get this redistributed route. Well, now I have a route over to 10.1.5.1, I believe is the IP. There we go. And so now I have connectivity over there, and this is why the lab had you back in step 2 use the next hop IP when we configured it on router 2, because when you use the exit interface, this route would have been in there right away, and we would have had connectivity right away. They wanted us to wait until we got here to take a look at that. So if I were to say, or actually we'll have to answer the question. First it says, why does router 1 only have R2's static route to router 3's LAN? What do you need to do so that R1 includes the previous EIGRP routes, which means the connected and the summary routes? And so the first part of the answer is, well, it only sees that static is because we configured EIGRP stub static. and we didn't use any of the other keywords, right? So what do we have to do to fix it? Well, we've got to go back to router 2, and we need to add in EIGRP Stub static connected summary, right? And so as you're learning, these options, they're mutually exclusive, right? So I can use stub by itself, I can use connected by itself, I could use summary by itself, or I can group them together and mix and match based off my use case, right? But the key thing is that they're mutually exclusive. You don't have to use one with the other unless it fits your use case. So on router 1, let's do a do show IP EIGRP neighbors detail, and let's see what it shows here. And there you go. Stub peer advertising static routes. All right. So let's jump back over to router 2, and we're going to make some more changes here. Do show run section. Let's see what we look like right now, and we should have a pretty good idea, right? We have our EIGRP stub static. Okay, so let's go ahead and change that. We want to add in those other routes. So EIGRP stub, we want the static, I want my connected, and I want my summary. And what other choices do I have? At this point, all I've got is redistributed and leak map, right? So, but we're just going to go with stub, the static, connected, and summary options for the stub. And let's see what happens here. It's going to tear our adjacency down, and it's going to reestablish that adjacency. So if I say do show IP route, what are we going to see? All right, so not only do we have our static that has been advertised or originated from router 2, we also have the 3 routes that we were looking at earlier, which is the directly connected, the 2 directly connecteds, the 10.3.3, the 10.4.4, and our summaries back. And again, the reason for this, and we'll do that show neighbor detail, and you can see right here, stub peer, which is 10.2.2.2, is advertising connected, static, and summary routes, right? Okay. So now let's go back and take a look at router 2's do show run section EIGRP. And this is going to look just like we would anticipate it's going to look. We have our EIGRP, our stub, connected, and our static. Or, I'm sorry, connected, static, and summary. And then it wants us to confirm we've got connectivity between router 1 and router 3. We've kind of already done that, but let's go ahead and say do ping 10.1.5.1 to make sure nothing changed. That's great, it works from there. And then router 3, do ping 10.1.1.1. And there you go. So we've got connectivity from the hub distribution router through the stub branch router over to the LAN segment behind router 3. All right, so now moving on to step number 5. So configure and verify EIGRP stub routing option receive only. Now the key thing about the receive only option is it basically prevents the stub from sharing any of its routes with any of its other EIGRP neighbors in the autonomous system, right? So what's going to end up happening here is we're going to apply this option, and we're going to see that it's not a very common option, but it is an option. And the lab points out that sometimes you'll see it used if you have a single interface with NAT-PAT configured, if you have a hidden host behind the stub router for whatever reason. So I don't want to say, I guess it's a corner case, but again, it's an option. And let's go ahead and take a look at that. So if I say EIGRP stub and I say receive only, and I do a question mark, you'll notice that iOS is smart enough that it sees here that you're using receive only, and receive only is an option that cannot be used with any of the other options. And the obvious reason for that is that we're saying that we're not sharing anything. We are only going to receive routes that are being shared with us. We're not interested in sharing any of our routes. And so let's watch what happens here. And this is definitely going to tear the adjacency down and then reestablish the peering. Now let's come over to router 1 and say do show IP route, and let's see what we see now. So you can see what receive only did. You can also see why it does not work with any of those other options, because those other options would advertise the routes to the peer here, router 1. However, when I say receive only, it's not going to share any of its routes. It's only going to receive advertisements. So back here on router 2, do show IP route. You can clearly see that I'm receiving routes, right? So there's a route from router 1, and we've got a route from, well, we have our summary, right? The null 0 route. If something comes in that's not going to a more specific summary component route, then it's going to get black holed to null 0. But we are learning EIGRP routes. And so that's what do show run section EIGRP, that's what the receive only option is going to do for us. And typically in situations like this, where you've got a hub and you've got maybe a branch office over here that's the stub router, is that the hub would simply advertise a default route, right? So the lab isn't going to ask us to do that, but that's something to think about, right? Is that would it make sense to just throw a default route over here to router 2, telling them, hey, I'm your next hop, come to me to get out, because that's the only way router 2 has to get to the headquarters network and theoretically to get out to the internet. All right, so let's go back over to router 1 real quick, and let's run that command that we have become familiar with here, the show IP EIGRP neighbor details. And what do we see? So it is a receive only peer, and what kind of routes is he advertising? He's advertising nothing. He's advertising no routes. All right, so we've taken a look at a number of the different options there. Now what we're going to do is we're going to go ahead and do what's called a leak map, right? And it's not part of the lab, but this is definitely something to know. And the text does mention it, and it will become relevant as you continue on in your studies. So what is a leak map? Well, a leak map is a way for me to advertise not only the summary route that I want to advertise, and in this case it's that 192.168.0.0/21, but a leak map will allow me to leak out one of the component routes of that summary. And there's a couple reasons why you might want to do this. So the first reason you may want to do this is if you're trying to do what's called longest match routing, right? And in this scenario here, not 100% relevant. However, in more complex and more complete configurations with EIGRP, when we're talking about 10, 15, 100 routers, you may want to force other routers to route to a more specific prefix rather than having it use the summary. And so let's go ahead and we're going to fix our configuration here. So I'm going to say EIGRP Stub, and I'm just going to hit enter. And we're going to go back to the way it was, and we're going to advertise what's the default. If you're thinking connected and summary, you're right. So again, by default, if I say EIGRP Stub, I'm going to advertise my connected routes, and I'm going to advertise my summaries, right? So if I say do show IP route over here on router 1, what should we see? You've got it. We're back to the original routing table, and we have this summary right here. So let's say for whatever reason that I want to leak loopback 3, right? I want to leak loopback 3 and have that be advertised in addition to the summary. Because again, loopback 3 is a /30. That's a more specific match than the summary is. Remember, the summary is a /21. So when we go to route, we're going to route, we would choose the 192.168.3.0/30 network over the summary. And again, if you're trying to do longest match routing, this is one reason why you would want to do that. The other reason why you might want to do it is because maybe, that we've got some other routers over here, and for whatever reason, let's say this is router 6, for whatever reason that router may be hanging, that route may be hanging off of router 6, and you want to make sure that when it comes through router 2, that it's using that longest match to get there to that component, and that if that component, if this goes away, you do not want traffic to continue to come through. Even though the summary would still be there, it would definitely notify, there would be a query sent that this route has gone away. All right, so let's go ahead and take a look here at router 2, and let's set up our leak map. Right, so we're advertising our summary, and so there's a couple ways we can do this. The first is we can do what's called an access list. So if I were to say IP access list, and let me jump out of the router config real quick. So IP access list, and we're going to name our access list. We'll make it a standard access list, and I'll say that this is just loopback 3 leak, right? And I'll hit enter. We'll say permit 192.168.3.0/30. And it's not going to want that. Sorry about that. I'm in the prefix list mood here. All right, so there we go. So we have our access list. So if I say do show IP access lists, so there it is, and the name is LO3-leak. All right, now that I've got the access list, so what is a leak map? Well, a leak map is really just, it references a route map, right? So, and you'll see when we drop the leak map in there, all we do is say, you know, leak map, and then we give the name of a route map. So let's go ahead and create that route map right now. So I'm going to say route map, and we'll call this, I like to usually say AL for access list, and then leak LO3. And permit 10. Now, when I say match IP address, this is very, very important right here. You'll notice that now it wants me to go ahead and give the IP access list name. When we're using a prefix list, we need to be very careful that we put in the prefix list option keyword here, or else it's going to interpret what we enter as what I'm doing right now, which is it's going to think it's an access list, and the parser doesn't toss up an error. It'll take in, so if I were to type that in and hit enter, it's going to take it. It's not going to give you an error. So you need to be careful, and we'll see that when we do the prefix list, what happens there. So I'm going to say match IP address, and the name of the access list, and let's go ahead and copy and paste that, is LO3 leak. And that is it. So I'm just basically matching that IP address, LO3 leak. All right, so let me go ahead now and head into the router EIGRP 100, and we're going to say EIGRP Stub, and actually I apologize. I'm going to dump this on my summary statement. So let's go into interface serial 000, and if I say do show run interface serial 000, so there's my summary, right? So if I were to cut and paste this here, and do a question mark, you can see that this is where it asks me for the leak map keyword. So allow dynamic prefixes based on the leak map. So I would say leak map, and then what's it looking for? It's looking for a leak map name. Well, the leak map is, all it is that route map I created earlier. So let's grab the route map name here, which was AL leak LO3. We'll say copy and paste, and I'll hit enter. And so what do you think? Is it going to tear the adjacency down, or is it a graceful restart? So remember, it's going to be a graceful restart as we're tweaking that summary, right? So let's take a look and see if it did what we wanted it to do. So do show IP route, and take a look at that, right? Pretty cool. So now I've been able to leak the more specific component prefix in addition to still having the summary route, right? So let's go ahead and take a look at the second way to do it. So we just did it with an access list, and I actually didn't want to jump over here to router 3. We just did it with an access list. Let's go back to the beginning here, and I'm going to show you how to do it with a prefix list. right? I prefer the prefix list way of doing it, just like prefix list better. So I can use a prefix list as well as an access list. So let's say IP prefix list, and I'm going to give the name, and so we'll call it the same thing. We're just going to say that this is going to be, and what did we call it earlier? Well, we'll just call it leak LO3, right? So prefix list leak LO3 permit 192.168.1. I'm sorry, I don't know if I leaked out 3 or not. Let's make sure we get that right. 3.0/30, right? And so we're going to match that exactly. 192.168.3.0/30. Okay, and so now it's the same thing, right? Remember, we did an access list with a single entry. Same thing here, except I'm just calling it IP prefix list leak LO3 and permitting that individual network to be leaked out. If I come over here real quick to router 1 and say do show IP route, what do we see? So remember, we pulled the summary off, so I'm getting everything right now, right? I'm getting, because there's no summary statement on that interface, on interface serial 000. Therefore, we're seeing all 4 component routes, but we're going to fix that. So let's create another route map. So I'm going to go ahead and say route map, and we're going to call this prefix list leak LO3, and we're going to say permit 10, and then match IP address. And now this is critical right here, right? So you can see if I typed in, if I simply drop this in, what would it be referencing? It wouldn't be referencing my prefix list. It would be referencing what it thinks would be an access list name, right? So this is very critical that we get that prefix list keyword in there prior to the prefix list name. So match IP address prefix list leak LO3, right? So if I were to go back to interface serial 000, and we'll pull back, see if it's still there. And so what do I need to change? We'll change the A to a P. Actually, we're going to change it to a capital P. And let's go to the beginning of the line here. We'll pull the no out. So IP summary address EIGRP 100. I'm going to re-add my summary with a leak map here. And the leak map it's referencing a route map, right? So when I say leak map, what follows is the name of the route map, and then that route map is just pointing to my prefix list. So let's see, we've got our graceful restart. Has it cleaned up our routing table at all? All right, take a look at that. Fantastic. So we've got our summary route here, and my prefix list, aka my route map, aka my leak map, has allowed me to leak out that specific prefix. Now, here's something that's interesting. So let's say your boss comes to you and says, yeah, you know what? I want you to leak out the loopback 2 network as well. How would we do that? Well, let's take a look. We know that we need to add something to the prefix list. So if I say do show run, or I'm sorry, do show prefix list, and let's get out of there totally. So show IP prefix list, I believe. Yep, show IP prefix list. If I hit enter, you can see that we've got that single prefix list. So back in the global config, if I were to say IP prefix list with my existing prefix list and do a question mark, we're going to permit 192.168.2.0, we said, /30. So now let's say do show, and it's going to be IP, and I'm going to paste the rest of that in there. What's it look like now? So it automatically added my entry for me here, and it gave it sequence number 10. And it basically it'll increment them by 5, right? So 5, 10, 15, 20. So as you can see here, now I'm actually leaking both routes. However, is that change going to be picked up auto-magically? Are we going to see that? You'll notice the routing table is not, you don't see it leaking the 192.168.3.0, right? It's certainly not leaking that out. So what I want to do is, and I'll do it over here on router 2, let's go ahead and we're going to do a soft reconfiguration of the EIGRP process. So I'm going to say clear IP EIGRP, and we're going to do neighbors. I could do the neighbor, we'll say soft, so neighbor soft. And so what is this going to do? So it says I manually cleared it, but what type of restart is it? It's a graceful restart. So that's how I can force EIGRP in a non-disruptive and non-resume generating way, get it to reread its routing table and then re-notify its peers as to the change. And then it's going to reshare its updates with those peers. So now if I were to say do show IP route, what would we anticipate we're going to see? And there it is. And so that's really all a leak map is, right? It's just a route map that references either a prefix list or an access list. And the prefix list and access list, all they do is say permit, and then you put the network in that you'd like to have the route map leak out via the leak map keyword. And again, the key is to remember that that leak map statement is show run interface serial 00. The leak map statement is going to be on the interface where you're doing the summary. So you just basically piggyback it onto the summary. And the reason that it's on the interface is because remember, EIGRP is much different than OSPF. OSPF, where do we have to summarize? At the area border router, right? So OSPF, we can only summarize at the ABRs, and the reason for that is because you've got that link state database. And that database needs to be identical on every peer in the same area, right? With EIGRP, that's not the case. EIGRP is distance vector. So it knows about its directly connected neighbor, and whatever that directly connected neighbor is telling it. It doesn't care about neighbors that are behind the directly connected neighbors. And therefore, because EIGRP is distance vector, I can summarize anywhere in the network at any time. And again, this is how I could leak out different routes. And so what does our prefix list look like? There it is. And that's it, right? And so as you grow and change your environment, you can make different changes or make, leak different routes and just basically piggyback them onto your prefix list. Okay, so the final thing we're going to take a look at, and this is what I'd mentioned at the beginning of the video. I actually, like I said, was fortunate enough to talk with Donnie Savage about this. And it's the reason, again, Cisco published, or Donnie actually wrote, along with a gentleman by the name of Don Slice, wrote the IETF draft. It's Draft Savage, and let me see if I've got, we'll pull this up here. So it's Draft Savage. And so here, if I were to type in IETF draft Donnie Savage EIGRP, we should get a hit. There it is, Draft Savage. That's what we're looking for. All right, so here is the IETF draft. And this actually just gives us some high-level information. Let me do this here. Let's go to Google. And I want to see this as a PDF. Here we go. All right, so there's draft 2, which is the most recent one. And so this has been released to the IETF, where Cisco is now saying, we're going to go ahead and make this open, that we're going to make the EIGRP code open to other vendors who wish to implement which is unquestionably the best distance vector protocol that's out there. And so we're interested in generic, and where was that at? Let me search for the word generic here. Yeah, generic TLV values, right? So we're going to do some debugs here. We're going to take a look at these values, and you're going to see why the stub feature is not included and how EIGRP communicates with his neighbors an EIGRP router communicates with the neighbors to tell the neighbors, hey, I'm a stub, I'm stub connected, I'm stub summary, I'm stub summary and connected, and we're going to see all those different values. And the one value we're very interested in is the peer information type value 0x0006 or 0006, right? All right, so let's go ahead and on router 1, I'm going to say debug IP EIGRP, it's hello, and debug EIGRP hello. Make sure I get this right. Is it packets hello? There we go. And it should give me a detail option. Now, what's very important here is you'll notice that this is 15.3 code, right? So I'm running the 15.3 branch of code here. Okay, and that detail option that's going to give us all of this great information, and there you go, right? So there's your type length value. So these are the TLV values in the hello packets, and it shows you router 1 is receiving these, tells you who he's receiving them from, right, his neighbor 2222, and we see some interesting values here. Now, I'm going to kill this in a second, but first I'm going to go back and onto router 2, and we're going to make one small change, right? And let me actually scroll down here. Actually, I think I need to scroll up. So there are the TLV values, and there's a specific one I'm looking for. So it's 6, and when you get down to 6, you can see here the peer information type, right? So the peer information type, it says this type length value, this TLV, is reserved and not part of this IETF draft. Well, it just so happens that this is the value that is being communicated from router 2 to router 1 so that router 1 knows that router 2 is a stub. And we're going to see that, and we actually do see it right here, right? So I'm going to go back over here real quick and make a change on router 2. We're going to go into router EIGRP 100, and I'm going to say no EIGRP stub. So we'll get a graceful restart, but let's come over, let's watch what happens here. And real quickly while we're watching this, so this type F5 value that we're seeing, so F5 represents the multi-topology routing information. And when I spoke with Donnie, I asked him about this value specifically because you'll notice it goes away. You see that? The F5 value is no longer here. It was here, but now it's gone. So let me say you all. So we're going to turn debugging off here, and we're going to scroll back up to where we had some received information. And you'll notice we're getting a type 1, type equal to 1. The length is 12. It's typically in bytes, right? And the type is a binary code, and this is going to indicate the type of field. And so that's what you're seeing over here. So here are the types. So if I were to scroll back up, type 1 is what? Type 1 is a parameter type. And so this type length value is used in hello packets to convey the EIGRP metric coefficient values. So these are the K values. So you can see right here, type 1, the length is 12 bytes total, and it says vector, and so that's synonymous with value. So again, this is where the whole TLV thing comes from. Type, length, value, right? And here are my values in hex. So now if we take a look at this, we see that, okay, type 1 are the K values. It says as well as the hold time values. So the TLV is also used in an initial update packet when the neighbor is discovered. So if I scroll down a little further here, here is what the K values associated with the composite metric look like. And remember, by default, we've got K1 and K3, our bandwidth and our delay. Okay? And this is the value in the hello packet that's communicating that information. All right, so type 4, what is the type format? So let's scroll back down a little further here. And this is one of the great things about this being now opened up to the public, is that you get a peek at the internal operational setup of EIGRP. So that's the software version type. So field and then length. So you've got a vendor OS major version, minor version, EIGRP major revision, and minor revision. It says it's used to determine the TLV format versions. Routers using version 1.2. TLVs do not understand version 2.0. Therefore, version 2.0 routers must send the packet with both formats in a mixed network. And so then you can see we have our value here. Now, you'll notice that 6 went away, right? The peer information type value. So let's kick our debug off again here. Debug EIGRP packets hello detail, right? And we should start seeing some information rather fast. And so there's our send, and here's our receive. And so as you can see, what are we sending and receiving? In normal operations, router 2, right now, remember, router 2 is not a stub right now. Router 2 is just another regular EIGRP neighbor who's out there participating in the autonomous system. And so router 2 is sending to router 1. Remember, we're watching this on router 1. He is sending the type 1 and the type 4. So he's basically sending his software type information, and he's sending his K value information, right? Because remember, those K values have to match for the adjacency, not only to establish, but to remain established. That's why they're in these hello packets, right? So now let's go make a change on router 7 here, and let's say router EIGRP stub. And I'll hit enter. I'll quickly scoot over here to router 1, and let's see what happens. All right, and right now we've got the type 1. Where are we at? We're receiving type 1 and type 4. Am I in the right place here? Hold on one second. Do show run section EIGRP. And I'm going to say no redistribute static. I misspelled that, so let's grab this guy here. Oh, and wait a second. Is that do show run section EIGRP? Am I not in the router EIG? Oh, yeah, I should be there. Router EIGRP 100. No router EIGRP stub. Show run section EIGRP. And this is throwing me here. And router EIGRP 100. No redistribute static. All right. So we should be able to say oh, did I say router EIGRP stub? It should have errored. All right, EIGRP stub. And we'll just leave it at that. EIGRP stub. There we go. So it tore down the adjacency, it rebuilt the adjacency, and there's the multi-topology routing value. And while it's running, I'm going to let it go until that value goes away. So in talking with Donnie, he explained that the MTR, the multi-topology routing type, as well as the value, that those really aren't used anymore. Cisco, it was something that Cisco was going to pursue, the whole multi-topology routing concept, and it just kind of withered on the vine and really didn't get much traction. However, that value is still in here, and it's one of the first values in the hello packet that gets exchanged. However, we are very interested here in value 6. So I just turned router 2 into a stub, and we'll let that go by one more time. So I just turned router 2 into a stub, and let's take a look at what he's sending now. Type 6, length of 6 bytes, and the value is 000D, right? And so here it is. That is why this peer information type value is not part of the standard. And this is when people say, oh yeah, well they released, Cisco released it, but they held back the stub feature. So this is why, or I should say, this is how you can validate that type 6 is the stub feature. You can see it right here. And also in speaking with Donnie, he had mentioned that they wanted to release EIGRP without the stub feature to see if there was a lot of traction in the industry to have other vendors take the standard and implement EIGRP for their own platforms. And then if there is, then they would go back, and as you can see, it's reserved, right? So this is going to be a quick fix for them to go back and to add this feature and functionality in. But the key takeaway here is there is the value. Now what's interesting, right, the vector, it shows up as 000D, which I believe is 13 in decimal. So what kind of a stub did we set up here? So if I say do show run section EIGRP, right, you can see it says stub connected and summary. What if I say EIGRP stub and I just want to do connected? You'll see it's going to tear the adjacency down. Let's kick our debug back off. And let's see, does that value change? And I'm just going to let this flow here. We'll be able to catch it. So sure enough, it changed. And so this is in the hello packets, right? This is how EIGRP communicates when you flip the router to a stub. This is how I'm telling my neighbors, yeah, I'm a stub, right? The TLV type is 6, okay? And the length is 6 bytes, but what's the value? What kind of a stub am I? Well, this shows that I'm only doing connected when it's 0009. What if I said, if I just wanted to do summary? Does that change the value? Let's see. Let the debug run. We're going to wait till we receive our next round here. And sure enough, if it's only summary, it's 000 Charlie right there. You see that? And so this is how EIGRP is signaling his neighbors in the hello packets. So what if I want to be a summary and connected? And I think we already saw this one. I think this is 000D. There you go. Picked it up rather quick. Right? So 000D. What if I want to be stub, summary, connected, and redistribute? What does that look like? And then it changes it to 1D. Now, what if it's receive only? That's a good one to check out here. Let's see if I were to say stub, receive only. How does he signal the neighbor? What value does he use? You can see he uses value 8, right? So the value is 8. And so again, right, we've talked about quite a bit here. We took a look at the Internet Engineering Task Force draft that was created here. We'll go to the very top. Donnie Savage and Don Slice. Do not know those two individuals there, but Donnie Savage and Don Slice, who have been working with EIGRP almost since its inception. So they are definitely the brain trust here, and this is the draft. It's a good read, right? If you want to learn about the internals of EIGRP, there is no better way than to take a look at this draft. And again, we're talking about values in hello packets. So if you're interested in what the hello packets are doing, right, this is going to tell you all about that. We took a look at the different ways that we can, the different types of stub that we can make this, right? So we made it a stub, and then we said, you know, do receive only. And then we did a stub, we did connected and summary. And the defaults are connected and summary. If I just say EIGRP stub, that's what we get. We took a look at a leak map, right? You know, let's go ahead, let's summarize. And then if I wanted to do longest match routing, or if there's, for whatever reason, I wanted to make sure that a component of the summary is going to be advertised on his own, we saw how to do a leak map. We did that with both an access list and we did it with a prefix list. My preference is definitely prefix list, but again, you can do it both ways. And so then you take those access lists or prefix lists and you reference them in a route map, and then that route map on the interface where you're doing the summarization, you reference that as your leak map, right? Okay, so this definitely wraps up Lab 2-2. Again, really good lab. We covered a lot of ground here, and so hopefully you've got a much better understanding of EIGRP Stub, as well as that unpredictable, or I shouldn't say unpredictable, but maybe unexpected behavior that you might see if you create a static route, and that static route references an outgoing interface as its next hop, and you have an EIGRP network statement that will include, or that would include, the destination prefix of that static route. And then you end up generating an EIGRP route. And again, that is not a bug. It's not a mistake in the code. That's exactly what EIGRP is supposed to do, because iOS is telling it, hey, this is directly connected. And therefore, EIGRP will scoop that up and it'll advertise it out as a directly connected internal route. All right, well, I really appreciate you watching. I appreciate your time. And again, I apologize for the audio issues with the last video. I'm not sure why that happened, but this has definitely cleared that up. All right, have a great night, and I'll see you soon.